Hi all, and welcome to the Emergent Vision Technologies presentation. I'm John Eilert, President, CTO, and company founder, and I look to provide details of how Emergent supports high-speed imaging applications from start to finish. As everyone would know by now, Emergent has pioneered 10 GigE, 25 GigE, and 100 GigE camera development. We are not your typical camera company, but rather make it our responsibility to make the technology accessible to all, which means providing the appropriate tools like optimized software, third-party component validation, and even turnkey and consulting services so our customers can hit the ground running in high-speed and high-performance imaging. Here's a quick snapshot of the adoption of GigE Vision products ranging in speeds from 10 GigE up to 100 GigE. Emergent has shown how top performance can be achieved and opened up many markets, including machine vision and entertainment, to the use of such technologies. Some companies are just now leveraging our efforts towards releasing 25 GigE and higher speed product, but still a ways to go to provide ratified, mature, and performance product. A new and exciting NVIDIA computer has hit the market in the DGX Spark, which is a fully integrated computer with built-in GPU and even a built-in dual-port ConnectX 7 NIC. Any Emergent camera can plug directly into this unit and gains immediate access to the powerful NVIDIA Blackwell GPU via zero copy and GPUDirect access. And no, these QSFP28 ports or other NIC ports are not compatible with CXP over fiber nor CameraLink HS cameras, which have opted to adopt the Ethernet physical layer from the IEEE. For these protocols, expensive adapters would be required to bridge to NVIDIA product. Here we've installed eCapture Pro and eSDK Pro on the DGX Spark. What you see here is the system or hardware view, which is all plug and play. We have our camera feeding one of the onboard ConnectX 7 100 GigE ports. When streaming, the camera feeds images directly to the internal GPU. In the processing view, we have simply created a plugin, which is largely a cut and paste of an off-the-shelf NVIDIA pose estimation algorithm. The output of the NVIDIA algorithm is simply XY coordinates, which we use to superimpose the graphical wireframe over top of the input image. We then output this image to our eSDK Pro built-in image display plugin to produce the output you see here. All of this is handled within the eCapture Pro drag and drop interface. Back in the live view, we start the pipeline and can view the input image as well as the processed image. Here we are streaming and processing a 16K 400 kHz line scan image. This computer is using an NVIDIA RTX A5000, and we are streaming images via GPUDirect to this GPU, where a simple custom brightness plugin has been instantiated. The output is currently just being piped to a display task so we can see the raw and processed images in the live view. Similarly here, we are streaming and processing an 8K 1 MHz TDI line scan image. We increase the TDI stages used here to show the expected intensity improvement. As we have seen, our software and systems expertise allows you to scale system processing to meet the requirements for higher performance applications like this. FlexProc stands for flexible processing, which is the simplest way for a user to create and test their machine vision algorithms. The user can create custom CPU, GPU, and FPGA plugins and run on low to high performance hardware systems without the need to write low-level image capture code. FlexTrans stands for Flexible Transport, which is the simplest way for a user to pass image data and results anywhere in their system. And it is done using the best-in-class zero-copy and GPUDirect technologies. Combined, FlexProc and FlexTrans lead to maximum performance, rapid prototyping, and endless processing flexibility and endless scalability. In this demo, we have 2 servers and 4 GPUs to distribute the processing of 8 25 GigE cameras. Here again, the plug-and-play architecture of eCapture Pro shows the hardware in the system view. In the processing view, we have dropped in an off-the-shelf NVIDIA machine learning algorithm, which performs a classification and segmentation task to allow detection and notation of humans. This algorithm runs on GPU 1. We transfer the results to other GPUs for subsequent annotations, and we drop in display plugins along the data path to view the incremental results. In the live view, we start the pipeline and view the results for each camera in the 8 vertical independent pipelines associated with the 8 25 GigE cameras. In this demo, we also have 2 servers and 4 GPUs to distribute processing for 36 Aeros 10 GigE cameras in this 4DGS or 4D Gaussian splatting implementation, which also includes a microphone synchronized like the cameras via PTP to 1 microsecond accuracy. The camera group feeds all 4 GPUs via multicast, and each GPU manages its share of the Gaussian splatting workload. Now let's play back the results of the pipeline, which reconstruct the whole 3D space, which allows us to navigate via joystick or goggles to anywhere within this space for a complete immersive experience. While Emergent has been shipping 100 GigE cameras for over 7 years, the sensors, while still very good, were front illuminated. Not only has Sony announced sensors now capable of 100 GigE speeds, but these will also follow their Gen 4 pixel architecture, which is based on backside illuminated sensor technology, which allows very high quantum efficiencies for greater sensitivities, which is a great benefit when going ultra-high frame rates, where exposures need to be kept shorter. For line scan, Emergent is now shipping cameras supporting 8K TDI at 1 MHz line rate and 16K TDI at 500 kHz line rate, which are a big hit for applications like battery inspection or other line scan applications needing high line rates with lower lighting requirements. Emergent has, of course, had its own integrated Canon EF mount design for close to 7 years, but Canon EF mount is going end of life. With the assistance of the detailed Canon specification, we have completed and already shipped multiple fully integrated camera modules utilizing the new RF mount. Micro Four Thirds options are also now available. As we have seen many times before, Emergent has full support of NVIDIA GPUs, which seems to be increasing in performance at a phenomenal rate. Here we have provided zero copy and GPUDirect for over 7 years on Windows and Linux. As part of our validation process, we test and fully qualify a number of such off-the-shelf cards from our primary vendors Broadcom and NVIDIA Mellanox, where both Linux and Windows are supported. We do remind that Emergent's own FPGA-based NIC grabber hybrids remain available for those looking for truly long-term support and additional FPGA-specific features, and/or front panel trigger akin to traditional frame grabbers. I note that Emergent NICs now have full GPUDirect support on both Linux and Windows. I also need to note that while some claim to have or are working on GPUDirect for both Linux and Windows, it is strongly advised to see proof of true GPUDirect. There are a few tools to view the system memory bandwidth utilization. It's not to be confused with capacity utilization. And a GPUDirect implementation should not have any utilization on the bandwidth side of your system memory. Also, be very wary of those promising or working on such development, but rather insist on having this up front before committing to any vendor. Our eSDK is a fully featured and very powerful SDK, which has formed the basis of some impressive applications over the past decade. eCapture Pro is built on top of this SDK and is a UI-based program which allows rapid prototyping of performance multi-camera applications using GPUs or other processing resources via our plugin functionality. We now introduce our eSDK Pro, which is also focused on performance multi-camera systems, but now allows developers to write a very small fraction of the code required by typical SDKs in order to complete the application for a far simpler integration and quicker time to market. Here we show how easy it is to integrate third-party devices into your eCapture Pro or eSDK Pro application via our plugin API. Opto Engineering provides LED pattern projectors. Advantech provides generic I/O cards, and we will use this card to trigger the LED. Zaber provides encoder-based rotary stages, and this stage will be used to rotate the PCBs on the turntable and to trigger the camera. The stage will provide triggers to the camera as a PCB is present. The camera will provide images via network card and GPUDirect to the NVIDIA GPU, where defects are detected using an unsupervised deep learning approach, and an action is taken by turning the LED on to illuminate the defective part with a red X pattern. To set this system up, we simply create a small plugin for each of the third-party devices and then instantiate them in either eCapture Pro or using eSDK Pro. Here is a short video of the physical setup showing the turntable, illumination, LED, and the Emergent Aros 10 GigE camera. An overhead shot of the turntable highlights the need for machine vision techniques on this repeating very high-speed 8 PCB array setup. In the system view, we see the camera, the NIC port, the computer, and the GPU. In the processing view, we see the camera, the rotary stage, a number of display tasks, a couple of ROI tasks, a task to create an image array, the AI anomaly detection task, and the I/O task for controlling the I/O card and LED. Back in the live view, we start the pipeline. With the pipeline running, we see the camera output, the ROI for the PCB under inspection, the ROI for the PCB detection results, the detection heat map showing location and intensity of the defects, and finally the image array for all 8 PCBs in a rotation showing their most recent results. Here is a portion of the code that makes up the anomaly detection plugin task, which, as with other plugins, is created using the Emergent eSDK Pro plugin API. Init and dinit API are run when starting and stopping the pipeline. The process API is run while the pipeline is running, and in this case is responsible for getting the image and running the AI prediction algorithm, and then setting a flag for another module to indicate action to be taken. Here is a portion of the code that makes up the Advantech control plugin task, which is responsible for taking the flag from the anomaly detection task and pulsing the LED on the defect PCB. Here is a portion of the code that makes up the Zaber control plugin task, which is responsible for configuring, homing, setting up triggering, and running the stage. And finally, if the application is to be run in eCapture Pro, then all of this is handled in the eCapture Pro UI via drag and drop processes with plugins compiled and loaded as DLLs. If running an eSDK Pro application, then you write this code to create and connect all of the tasks and to control the application either by your own UI, command line, or what have you. For this code, you would use the Emergent eSDK Pro API. With such a broad range of products, we find it helpful to chart out the various resolutions and frame rates provided. At 10 GigE, the products range from 0.5 megapixel at 1500 frames per second up to 50 megapixel at 23 frames per second. At 25 GigE, the products range from 0.5 megapixels at 1600 frames per second up to 127 megapixels at 17 frames per second. And at 100 GigE, the products range from 2 megapixel at 3462 frames per second up to 152 megapixel at 16 frames per second, with a special nod to Sony's new 100 GigE worthy sensors. For line scan, the products range from 4K at 172 kHz up to 16K at 500 kHz, with a special nod to 8K TDI at 1 MHz line rate and 16K TDI at 500 kHz line rate. We are now in full production with our new Aros 10 GigE line of cameras, with all models seen here, which also includes models based on the Sony SWIR sensors. A note on SWIR: there is a lot of talk about the need to cool these sensors, but it should be noted that this is only important for exposures over 20 milliseconds over the full temperature range, which is not often required. And for over 20 milliseconds, there are certainly options to externally cool these small modules. All models are the lowest power, lowest cost, and smallest size options available. We have the AROS camera line operating at 10 GigE speeds, and for the RJ45 PoE version, the cameras can auto-negotiate to 5 gig, 2.5 gig, and 1 gig for lower speed operation. We do all this in an attractive 29 by 29 millimeter form factor. This is all made possible by the lowest power consumption of all 10 GigE and 5 GigE cameras of all manufacturers in the industry. In fact, the AROS operating at 10 GigE with PoE has lower power consumption than any 5 GigE camera in the industry. And very noteworthy is the feature set is not reduced compared to other models, and Emergent's same reliable and mature zero copy and GPUDirect solutions are available for an overall solution that is second to none. Here we will provide a snapshot of the features for one of Emergent's workhorses, with which one customer over the past 7 years has used in systems with camera counts as high as 512. Based on the Sony IMX530 sensor, this 25 megapixel model hits the sensor's max frame rate at 105 frames per second by utilizing the Emergent pioneered 25 GigE interface. Other highlights include a wide -20 Celsius to 50 Celsius temperature range, a 3-year warranty, fanless operation, lowest power of 12 watts, smallest size, modular SFP28 transceiver options, flexible I/O options, and of course zero copy and GPUDirect technologies. As we have seen, it is not just about the camera alone, but the complete software and support package that further sets Emergent apart. What is now very old news, the new machine vision standard GigE Vision 3.0 has adopted Rocky V2 RDMA support, which now allows zero copy transfers to system memory, thus equalizing performance with CoExpress and CameraLink HS, while allowing the use of lower cost off-the-shelf NICs. Since Emergent has always provided zero copy and more through our advanced and mature driver technologies, we naturally have adopted this standard, which can only strengthen our position in performance vision applications. To that end, Emergent has long released this edition with a simple firmware and software update with existing hardware, which was always RDMA ready. This includes all models in the Emergent portfolio, including our new AROS model. I do feel it is important to remind about the limitations of Rocky V2/RDMA compared to Emergent's mature solutions. The primary limitations are no multicasting support, which is a fundamental of Ethernet and streamed video technologies, no Windows support for Intel and Marvell NICs, no GPUDirect on Windows for NVIDIA GPUs. The last item about GPUDirect is very important and is a limitation of frame grabbers. Emergent, however, does have GPUDirect on Windows through our advanced and mature driver technologies. In contrast, the primary benefit of Emergent's advanced and mature driver technologies are listed below, which fill any gaps left by other vision standards, which essentially allows unparalleled flexibility. For the Vision 2026 trade show in Stuttgart this year, we are in the center of Hall 8 and looking forward to not one but 2 major product launches. I hope to see you all there. As you can see, Emergent has the highest performance camera and software portfolio all under one roof, and not via umpteen company acquisitions, and we keep our overall product portfolio focused. We innovate, design, develop, adapt, and expand the markets we enter, and have the foresight to do so. Please do contact us for further details, and we appreciate you taking the time to view our presentation.